Hello everyone, today we are going to draw a burner with air swirler. The geometry will be used later on for simulation in ANSYS CFD simulation, ANSYS-Fluint. Okay, now we can start drawing the outer shell. We'll be drawing a small size, about 4-inch burner. This is the common diesel burner, so the radius will be around 50 mm. Now we do the extrude. The length we can do about 500 mm for the outer tube. Okay, now we'll start drawing the cross section of the blades, the vanes for the burner. So we first have to draw a reference geometry for the cross section. So we choose a plane. Okay, this plane, since we are drawing in x-axis, so this will be the front plane. We can see from top view. Okay, the plane will be the outer diameter of the swirler. So we have to move the plane far from the front plane. Okay, a bit 55 mm. Okay, the plane is ready. Now we are going to sketch inside the plane. So new sketch, you can make it face us. Okay, now you should properly draw the geometry of the cross section using the SP line for the outer curve, inner curve, but for simplicity's sake we are using ellipse instead. So also you have to properly define the angle, and geometry here will be just doing arbitrary. We can do here 2 mm thickness. Okay, it's a bit far. We can pull it back a little bit, 20 mm from the 0 point. Okay, it is ready. Now we can do the extrude for the blade. This is one blade or vane of the swirler. This is obviously the wrong direction, so we have to reverse it. The diameter is about 100, so we have the radius 50, but this is a bit off center, is a bit out, so the plane is 5 mm outside, so we will do here 50. That will leave a distance from the center about 5 mm. Okay, now the important thing, you have to uncheck this merge result, so you'll have a separate body for this vane. Okay, now we have this blade or vane ready. We have to duplicate it, so we use a circular pattern. Okay, we don't want to use feature, we better use body pattern, so we choose our blade here. Then the guideline is this edge. We can see the preview here is too much, 12. For simplicity's sake, we don't want to load the simulation too much, but you have to decide for your own how many blades you want for the simulation. So we'll do like 10 vanes. Okay, now the vanes are not connected from the bottom, so we have to draw a ring to connect them. So we have to define first the reference. So the reference geometry, we have a plane. This time the plane will be the right panel. We see again from top. Okay, so we have to move it a little bit closer. Okay, that's enough. It is around 35 mm, so we have to remember this number when we do the injector later on. So this is good enough for the plane, 35 mm. Now we draw the sketch on this plane. What we want here is a ring but we cannot see, so we have to make this outer shell invisible for now. Okay, now we draw two circles. One is the inner circle. Okay, one is the outer circle. We can make it a bit larger. It's okay. Okay, these are the circles. Now we have to extend to make it like a bush, solid bush. Obviously it is the wrong direction, so we have to make it the other way around. We can actually make it long, so it will go outside, because we will remove this solid body later on. So we'll just extend it outside the shell. Okay, now we can see the whole burner. Okay, now we have to do join. Oh, we forgot something. This bush, we didn't uncheck that merge button, so we have to do the unmerge, so it will be a separate body again. Now we merge only this bush with the veins. Okay, again we do this one invisible. Okay, so we go insert, then features, then we have combine. We choose add, so we add the two bodies as combination as one body. Okay, so we have to choose manually all veins and the bush in the center, then merge them together. Okay, they become now one single body. So we have basically two bodies now, the outer shell and these veins. Okay, now we need to draw the last component, is the diesel injector or gas injector based on the fuel you choose. Okay, so we can choose this surface and draw a new sketch on the surface for the injector. So we don't want any air to go below this bush, so we'll make this injector exactly the size of the inner diameter of the bush or the lower ring. Okay, now we have to extend, so it will be as a rod or injector. Okay, so direction 1, we can choose direction 2 to the inside. Now we remember last time this plane 2 was 35 mm far from this 0 coordinate, so we have to do a slightly after that, so the injector will start inject after the burner, after the swirler, sorry. So we can choose the second one, 40 mm, 5 mm after the bush end or edge. Okay, so again unmerge, so this is a third body here. Okay, now what we want to do is subtract. First we can subtract this swirler from this main body, so we will choose insert, feature, combine, then we use subtract. So these will basically be a void, so we don't have extra body in simulation that will slow us down, so it will be just empty space, no fluid can go through there, just to make the simulation much faster, much easier. So this is the main body, then we have to subtract this one. So this basically will be a void, as we can see here. Now similarly we have to do with this rod, this is the fuel injector, so we subtract again. Okay, so features, combined, so this is subtract the main body, then the swirler, the injector, it will be also a void. So we can see here, since we did 5 mm extra inside, so this will be the boundary condition for fuel inlet, and this will be the boundary condition for air inlet. Now we can save it in a native geometry that can be used in most of the simulation softwares, including our software ANSYS-Fluint. So one of the native is the parasolid. The extension is X_T, so we choose this one as a native geometry. Okay, stay tuned for the next video. We will have the simulation in ANSYS-Fluint. Thank you.